Okay, your homework for Wednesday is page 411, and you are to do 1 through 27 rather. Odd. So we will start with problem number 1, and you are to graph y equals root x plus 1. You'll have graph paper today, so make sure that you use that. I'll pull up my graph paper here. There we go. And so the first thing you need to understand before I graph this one, if you missed it in the lecture, is that y equals root x is the inverse of y equals x squared, although its domain has been restricted. And what we mean by that is x has got to be positive or 0. So we're only looking at x's on this side of the y-axis. So if we were to graph this one in red, we can just plot points. X can be 0, and that gives you 0. X could be 1, square root of 1 is 1. And then you want to choose your next x carefully. You don't want to choose 2 for x. It would be much better to choose something like 4, because we can take the square root of 4, since 4 is a perfect square. The next one we could choose is 9 for x, but we don't need to. And so that's what we would call the parent function for all of these radical equations looks like. Now, when we have y equals root x plus 1, let's graph that one in blue, it's going to be exactly the same. However, because of that plus 1, it takes every x value you get and it bumps it up by 1. So instead of 0, 0, when we plug in 0, out comes a 1. When we plug in 1, out comes a 2. When we plug in 4, instead of a 2, out comes a 3 from the function. So this blue one is the same as the original parent function, but it's pumped up. So your final graph isn't the blue and the red one. Your final graph is just that blue graph. Now, they don't ask us for domain and range, but we can certainly look at the graph and say our domain is all x's that are greater than or equal to 0. And we can say our range in this case would be all y values. The lowest y value we have is 1, so it's all y values greater than or equal to 1. Let's jump to problem number 3 is very similar. 5. Let's jump to problem 5. I'll throw in another graph. So, in problem 5, we are asked to graph y equals the square root of x minus 3. The 3 is underneath the radical. Again, this is going to be very similar to the standard radical function that looks like this, except now notice that 3 on the inside. Okay? That 3 being on the inside means the values kind of shift. Normally, in y equals root x, when we plug in a 0, out comes a 0. Now that happens when we plug in a negative 3, we get 0. So this shifts the entire graph back to the left. So at negative 3, the function equals 0. When I plug in a 1, I get the square root of 4, which is 2. 1, 2. So negative 3 gave me 0, 1 gave me 2. Sorry, I've gotten this backwards. Yeah, okay, 1 gave me 2 right here. There we go. It still looks like it's a little bit off. That's alright. And negative 2 will give me 1. I should have counted from there. I got mixed up where I was counting from. So negative 3 gives me 0. Negative 2 gives me 1. 0 I don't want to plug in because 0 gives me the square root of 3. -1, I don't want to plug in, that gives me the square root of 2. If I plug in a 1, I get 2 out of it. And so there's that graph. And it is identical to the graph in blue, except it's shifted to the left by 3. Now we saw this quite a bit in a lot of our other functions. For example, when we were graphing things of the nature, y equals absolute value of x, we knew that was going to be an absolute value function, the slope of 1, and then we could shift it left and right by doing things like adding 3 to the inside of the absolute value. That would be the same absolute value function, but it would be shifted to the left by 3 units. And our radical functions do the same thing. That 3 plus 3 on the inside shifts it left by 3. Alright, 7 is very similar to that. Let's jump to problem number 9 now. 9 is a new section. Again, it's still graph each function, so it's the same direction, so we don't have to really make a new section for it. However, they did change what the functions look like. Now y equals 3 root x. So our parent function for this one is y equals 3 root x, not y equals root x, and we'll just generate some values. 0 gives us 0 again, but now when we plug in a 1, out comes a 3. So as we start to graph this, we can see it doesn't make that shallow sort of, I guess it is more shallow, it's not as steep a curve because it's upside down. 4 would give us 6. So 4 gives us 6, which is right there. So it's still got that shape to it, but it's not as severe. So this 3 out here, okay, makes it wider than if it were just a 1. And I'll draw the 1 again so you had that for reference. If it was just y equals root x, remember that's 0, 0, 1, 1, 4, 2. So that one is a really kind of steep turn. It turns rather abruptly, whereas the one in red turned rather slowly. It makes it kind of a wider curve. Let's see, 11. 11 puts a 1/3 instead of a 3. You'll see what that does. 13, pretty much the same thing. 15, the same thing. 17, we have a little bit of a change. Problem number 17, you'll see when you're looking at your homework, it starts to put a negative sign out in front of these. So 17, we've got y equals negative root x minus 1. Now we should start to notice that this underneath the radical tells us whether it's going to shift to left or right. In this case it shifts by 1. Normally, if it were just this, starting from that x is 1 point, it goes over 1 when x is 1, goes up 1. And then it could go over 4 and it'd go up 2. But because of this negative sign out front, as we generate values, they're going to be the opposite. So from our beginning point of our curve, when we plug in a positive 1, for example, we get 0. When we plug in a 2, we get negative 1. So this negative out in front has flipped it upside down. When I plug in a 5, out comes a negative 2. So here's 5, 1, 2, down 2. So it looks like that. And in fact, this is exactly the same graph as y equals x minus 1, which would look like this, but the negative sign flips it over on that x-axis. So we just want that blue section there for our final answer. 19 is pretty much the same. They're kind of throwing everything at you, and 21 is pretty much the same. So good luck on your homework.